Hi, hello, namaste, welcome to my channel. Today we are gonna look at physical world. So you would have just finished class 10 and you'll be entering class 11, or you will be studying for NEET or any other preparation as such. So we start with the chapter for class 11. So this is class 11. It is same for CBSE, ICSE, state board, everything. So this is the very first chapter, chapter 1, which is basically the introduction to physics. So the concepts will be same for all the class 11 students. So let's get cracking with chapter 1, physical world. In today's lecture, I'm gonna completely cover the chapter 1 syllabus for you guys. Um, so we begin this chapter by understanding the very basic question: what is science? So what do you mean by science? Science is basically exploring, experimenting and predicting. So you explore something, you experiment something and you predict. So that is basically science. So what is the meaning of the word science? It's a Latin word. The word science is derived from the word scientia, that means to know. Scientia is the Latin word. So another way of saying is it's a systematic attempt to understand natural phenomena and use the knowledge to predict, modify and control the phenomena. For example, uh, you know uh, the earth is rotating around the sun. So this is basically a natural phenomena that is being occurred. So the sun is at the center and all the planets are revolving around the sun, so which is a natural phenomena. So what we do is we try to apply the knowledge. For example, you apply the Keplerian laws to understand, to predict how the rotation and how the period is related to other variables. So we try to create a mathematical equation. So we look at something and we write it in the mathematical uh, language. So that's how math. So many people think uh, uh, without maths I want to learn physics, especially students who are joining NEET with PCB background. See, if physics is a car, if physics is a car, okay, and you know what is the fuel? You can take it as electric fuel or petrol, diesel, whatever. So the fuel will be the math. The math will be the fuel. So physics and maths are interrelated. So you can't say I want I will study physics and I won't do math. So you can't do that. So both are connect with each other. So now, in order to understand what is science, we have a scientific method to apply. So how do we apply? So we do apply a scientific method. We do a systematic observation, just like I gave you an example for a planet revolving around the sun. So we observe them using a telescope. Then we do controlled experiments, like we do measurements, what is the rotation, revolution, all those things can be done. Then we do quantitative and qualitative reasoning. Quantitative means you take a large data sample and do quantity, as the word quantity means. So you do it with very large data sets. Whereas qualitative means you look at a specific data set and you come up with certain ideas and present it to be more reasonable, and which involves mathematical reasoning. So that's where mathematics is always there in both the reasoning. So you need to apply mathematics, then you can predict whether what you did was false or true. So verification can be done and falsification also can be done. So this is how you apply scientific method. So if you think you're standing, so you will observe that you're standing, what are the parameters, you do the measurements and then you predict you can walk. Okay, so that's how, like that's how you can prove you're walking. So there are I said it in a very simple language, but you have to look at the way you're standing and the way the legs are aligned, and then you and also you can measure the speed of your walking, and with all those things you can prove that you're either walking or not walking using scientific language. So mathematics does come into play in every scientific language. So now in science we know we have many branches, and physics is one of the major branch. So physics is derived from the Greek word physis, means the nature. So what are the principles that thrusts in physics? One is called as unification. What do you mean by unification? You would have heard of the very famous theory of everything, right? So Stephen Hawking's book is also based on theory of everything. There are four fundamental forces which I will be coming in the upcoming slides: gravitational force, the electromagnetic force, strong nuclear force, weak nuclear force. So all the basic forces. So can you write one single equation? So combining all the four forces, okay, can you write one single equation? So that is a challenge. So that is basically one of the unsolved problems in physics. This is one of the major unsolved problems in physics. Anybody solves this, you will be more famous than Einstein. Okay, so that's how important this unsolved problem is in the world of physics. Then we do reduction. So we have, elimination, reduction. So when we see certain variables, we try to reduce it. Like, there is a vast amount of knowledge, so we try to reduce it and make it in a much simpler and elegant way to get proper solutions. So those are basic principles behind the physics. So what is the scope of physics? So we have two levels. One is macroscopic level and another one is microscopic level. So in order to understand what is macroscope and microscopic levels, let us quickly take an example. So in physics, what do? Is we do something called as measurements, right? So what are the basic physical quantities we start measuring? We will take an example of the major three: mass, length and time. Mass, length and time. Okay, and when we do measurements, we have actually three types of worlds. We can call it as Newtonian world, or uh, the correct name will be the classical mechanics. Okay, Newtonian mechanics falls under something called as classical mechanics. Okay, the world which we live in, basically where Newton's rules are applied. Classical mechanics is actually a broader area which has like Grantian mechanics, Hamiltonian mechanics, so on and so forth. So that is basically classical mechanics. And the tiny world, microscopic world, we know it is quantum mechanics, very famous. Then if you go to a bigger world, then we have relativistic mechanics to deal with. So if you go to a shop, you use the word of you use the language of classical mechanics, Newtonian language. So you can go and buy 1 kilogram of apple, 1 kg of apple. So kg is the unit of mass, and that is the language we use, because that is what we can feel and see around and compare it with. Then when we go to length, we know centimeter can be taken, which you can feel, 10 power minus 2 meters, sorry, 10 power minus 2, 1 centimeter is 10 power minus 2 meter. So you can feel the centimeter on your roller. So that is the length, total length that you can see. And when we talk about time, a blink of an eye, so seconds we can measure. So this is the language we use in. These are the number game we play with Newtonian mechanics. So if a question is asked in Newtonian mechanics and say, sir, I'm getting 10 power minus 31, 10 power minus 16, those are all not correct answers, because in order to get into the language of classical mechanics, you usually be around with these kind of number lines. So this is just to give you a scale of the problem. So when you're doing numericals, you should make sure you do understand the conversions properly. I'll be doing one more video on how to do conversions in the upcoming videos. If you want such videos, please leave a comment below, so that if more people do ask me, then it will be easy for me to uh, uh, you know uh, give you those videos. So let's go with the next part, which is quantum mechanics, QMech. So this is a tiny world, right? This is a small world. This was our world. This is a small world, and this is a big world. Okay, so in the small world, microscopic world, so what if you think about the tiniest mass, we can talk about the mass of the electron, which is 9.1 into 10 power minus 31 kg. See, 10 power minus 31 means the mass of an electron, which we can't even see from our naked eye. And you say the mass of some bob or something is of this order. When you do calculation in the lab, teachers feel like jumping off the building because of that. Okay, so please make sure you don't do such kind of, so you should have a feel of numbers, what answer at what range you should get. So if you, with that mindset, if you enter into a lab or any physics numerical questions, you will be able to solve it in a much simpler way. Okay, then what is the smallest length? We know it's a quantum length, so we can talk about I would say Planck's length, so which will be 6.610 power minus 34. So that is one of the smaller lengths we can talk with. It is in joule second, we can do the conversions. So that is one of the tiniest lengths we know, which is of the order 10 power, just giving you the feel of numbers. 10 power minus 34, that is 0.00, so many zeros. And when we talk about time, we have atomic clock which can measure till picoseconds, so 10 power minus 12 seconds. So this is how we understand the world of quantum mechanics. Then we have something called as relativistic mechanics, which is a bigger version. So you can imagine the mass of the sun, which is 2 into 10 power plus 30 kg. So if you do if you do a mistake in plus or minus, so mass of the electron, which you can't see, and sun is so massive you can't even hold in your hands, so that will be the difference. So you should be very careful with plus and minus. So minus, whenever we are putting 10 power minus something, it is 0.000 something. So this is after plus 30 means it is 2 after so many zeros, 30 zeros. So you have to be very careful when you are doing the problems. And when we talk about the length, we can talk about the distance between the earth and the sun, which can be one astronomical unit, which is 1.5 into 10 power 11 meters. So 1 AU. Basically with celestial object measurements, you can take one length, one astronomical unit. And then relativistic mechanics, we can take the rotation of the earth, which is 24 hours. So these are the numbers at which we try to understand our real world measurements. Okay, I hope that is clear. And alpha scattering experiment by Rutherford is one of the interesting experiment in science. So he did a gold foil experiment. Before this, people wanted to know what is inside the atom. People thought that there is something called as plum pudding model. It's like a watermelon. The red part was called as proton and the seeds were called as electron. Okay, then comes Rutherford. He did this experiment. He took some alpha particles, he made a hole in the lead bricks and made the light to go in straight line, and he put a gold foil. This is a thin gold foil. Okay, this is a thin gold foil. So once the alpha particles hit this gold foil, some went this side, some went this side, and some went this side. Okay, so sorry, some went this side, back scattered. So this is large angle, that's it. So and he kept a detector or a microscope here, which is ZNS screen, and the scattering angle was measured. From the scattering angle, he was able to say there was something called as nucleus at the center of an atom. This is positively charged, and this mass was responsible for deflecting alpha particles propelled through the gold foil. So he just thinks, just like planets go around the sun, right? So if this is the sun, planets revolve around the sun. He said proton is at the center and electrons revolve around them, similar to just this. But this model also fails. You will learn more in class 12 atomic physics chapter. This is just to give you an example of how the scientific experiments are used to create new knowledge in the world of science. So physics, technology and society, all of them go hand in hand. Energy industry, if you think about in energy industry, there are many aspects of the energy industry where we use physics. So you might be wondering, where is physics in the energy industry? So solar cells, solar energy. So basically, if you talk about solar cells and all the other yeah, optoelectrical cells, that basically comes under energy conversion. Then you will be thinking, why IT is computer, why are we saying physics comes in IT industry? So inside your computers there are semiconductor chips, IC chips. So if you talk about semiconductors, then physics comes into play. Then we talk about medical industry, so we have something called as medical physics. So your MRI scanners, ECG, all those things works on basic physics principles. And of course communication industry, communication in your if you think about your landlines. So if you, in the olden days of landline, if you said hello, the sound was getting converted into electrical, electrical was getting converted into light. And there is a concept called as total internal reflection through optical fibers. Optical fibers are the telephone cables. So inside that, using total internal reflection, the communication of used to happen, just saying hello and somebody is receiving hello. So that used to happen because of optical fiber and total internal reflection. And even if you think about nowadays with respect to mobile phones, your GPS locations, all these things work on Einstein's relativity concept. So the positioning systems and all those things. So we don't have so many satellites for GPS. So there is a considerable number. You can Google it. You will find an interesting answer there. Okay. So the final one is the space industry. So Elon Musk is doing SpaceX. He's a physicist. I should not end with those things. So if I say, if you think the trajectory or optimization of a rocket or anywhere, all those, and internal combustion of a rocket, all those, the thermodynamics comes into play with those internal combustion of a rocket. So if you think with respect to in terms of rocket, so physics does come into play, even including how to launch a rocket using basic rocket equation. Everything will be derived from the major concept physics. So physicists around the world and their contribution. So these are some of the famous scientists. Archimedes. So Archimedes is one of the ancient scientists. He did he plays an important role in fluid mechanics. There is a chapter called as fluid mechanics, or mechanical properties of fluids, as the name in your NCERT textbook. So he works on the principle of buoyancy and principle of lever. Okay, he is from Greece. And Galileo Galilei, you guys would have heard of Galileo Galilei, law of inertia, and he was from Italy. And Huygens. So Huygens basically comes in wave optics in class 12. So wave theory of light. Uh, he was from the Netherlands or the Holland. You know, everybody knows Newton. So law of gravitation, motion, reflecting telescope. He was from England. So Michael Faraday. You have a lot of studying of in class 12, starting from chapter 1. You will start with the story of Michael Faraday. Actually, Michael Faraday's work has affected almost all the chapters of the first 7 of class 12, like first 7 chapters. Some or the other way, if you means there are magnetism chapters in between, but still, if you go to chapter 8 where the unification happens, that was one of the major breakthroughs in physics. So you will hear a lot about Michael Faraday. He was from England. And James Clerk Maxwell. So this was a very good friendship between Michael Faraday and James Clerk Maxwell, which I will narrate the entire story when I'm teaching that, of when I take up the class 12 syllabus. So electromagnetic theory and light and electromagnetic wave. So electricity was a different topic, magnetism was a different topic. And Michael Faraday thought light is an electromagnetic wave, but he did not have the mathematical skills to prove it. So in order to rescue him, James Clerk Maxwell comes with 4 beautiful equations. Okay, which will marry electricity, magnetism, and you will get a very beautiful number, that is speed of light. So basically, in simple language, if I have to tell, he took electric field and divided magnetic field and popped out speed of light. So that's what James Clerk Maxwell did. Then Hertz, so generation of electromagnetic waves. Bose, ultra short radio waves. Rontgen, you guys would have studied X-rays. J.J. Thomson, electron. And Marie Curie, you know, discovery of radium, polonium, studies on natural radioactivity. Basically, she was Polish. Albert Einstein, you guys know. Einstein received Nobel Prize for photoelectric effect, not the theory of relativity. Many people don't know that, and many people think it's equal to mc squared or theory of relativity, but he got the first Nobel Prize was for photoelectric effect. And these are the physicists around the world with major contributions. If you are wondering, sir, should we by heart all these things? No, you need not. For the final exams, you won't get a question. This is just to give you a inspiration or a starting point of how to get into physics. If you get a question, you might get a question from one particular point. I will stress on that. And this is the link between technology and physics. For example, steam engine works on the scientific principle of laws of thermodynamics. This is just to get you used to what is coming up. Okay, so you should know, these are like basic general knowledge, what is connected to what. So it's like reading the contents before diving into the chapter. So for example, optical fibers, total internal reflection will come in class 12. So it is basically introduction of class 11 and 12 together. If for NEET or JEE or Karnataka CET or any exam you prepare, any board exams, anything you prepare, you should know what is what, like what is cooking inside the world of physics. For example, computers works on something called as digital logics, what are lasers, and the superconductivity and magnetism relationship, rocket propulsion and Newton's third law. Right, so Newton's laws of motion, electric generator, Faraday's law, hydroelectric power, gravitational potential energy into electric energy, aeroplane works on Bernoulli's principle, particle accelerators, basically motion of charges, large hadron collider. I would have given some videos, you can go and watch it. In one of my videos I have spoken in length about it. Sonar, reflection of, these are like basic introductions of what is going on. Non-reflecting coatings, basically thin film optical interference again comes in class 12. So it is basically introduction of class 11 and class 12, guys. And GMRT is a radio telescope which is located in Pune. It is used to detect cosmic radio waves. Not many people can detect radio waves. I don't want to talk about my stories here. Bose-Einstein condensate. So this comes in statistical mechanics in the higher classes, but this is basically connected to thermodynamics. So I was telling you, if you get a question, you might get a question from one specific topic. This is the topic. So fundamental forces in nature. So there are 4 fundamental forces: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. So gravitational force, so the force of mutual attraction between any two objects by the virtue of their masses. So if there are two masses, m1 and m2, the force of attraction, so we use the word only attraction for gravity. Gravity is basically an attractive force, and it happens between any two massive objects. So you can think this is one boyfriend and this is one girlfriend. So if there is a force of attraction, then you can say the gravity between them is very good. But don't write boyfriend girlfriend in examinations. Anyway, when we go about electromagnetic force, so the force of attraction and repulsion, so we are using two words here, attraction and repulsion between the charged particles, so q1 and q2. So this is charges, so it can either be positive or negative. So if there are two positive like charges, what do? They repel. Unlike charges attract each other. So I always tell this funny example. me and my wife are unlike charges, so we attract each other. If you want a repulsion, I don't want to talk about any. A friend is positively charged, another friend is positively charged. If your enemy is also positively charged, okay, if you are positively charged and your enemy is also positively charged, then you repel each other. Okay, because you both have the similar thing to fight. Then the third is called a strong nuclear force. So the force that binds protons and neutrons in a nucleus. So if you take an atom, proton and neutron is at the center and electron is there na. So the force of attraction that binds the force of attraction that binds between proton and neutron inside the nucleus, that is strong nuclear force. Then weak nuclear force. So it is the mechanism of interaction between subatomic particles that is responsible for radioactive decay. So if you take any tiny if you have seen if you have studied nuclear physics in your lower classes, you know what is radioactive decay. So with respect to time, something is decaying. What is it decaying? In the form of radiation, right? So this form of radiation coming out, the mechanism that is happening here is, the reason why it is happening is because of the weak nuclear force. And this is one of the important slides in this chapter. So usually you will be asked question with respect to relative strength and range. Okay, so gravitational force has a, you can see 10 power minus 39. So what is it? It's a very weak force. 10 power minus 39 means 0.00039 zeros, right? So very weak force. And many, I asked them what if somebody gives you a question which is the weakest force, many people will tick weak force because weak na. Don't fall for that trap. Gravity is the weakest force. Okay, please keep that in mind. Don't go with the English language, go with the actual relative strength. And it can go for a infinite range. So it can be in space. All objects in the universe, stars, planets, galaxies, everything is basically infinite. Weak nuclear force is 10 power minus 13, so very short subnuclear size. So some elementary particles, so I told you, no, elementary particles, shorter particles who work with weak nuclear force. Then electromagnetic force, which is also infinite and it works with charges. So strong nuclear force is the strongest force. Strong nuclear force is the strongest, but weakest force is gravity, not weak nuclear force. Keep that in mind. So it is short and nuclear size, and nucleons are heavier elementary particles. So these are the four fundamental forces of nature. And when we talk about unification of forces, these are the people who have played a major role. Isaac Newton unified celestial, like apple fell on his head and he saw moon. He is also rotating around the earth. Both are on the same. Unification means combining. I told you, one of the major principles of thrust of physics is unification. So similarly, Oyster did this. You learn these things in class 12, Maxwell till here. These things will go out of syllabus. Okay, so these are the things you are gonna study in syllabus. So the physics what you are studying is as old as 1873. Yeah, and after that they call it modern physics. Oh my god. Yeah, sometimes our syllabus needs to, sometimes I feel it has to go ahead. So what are the basic conservation principle? What do you mean by the word conservation? Conservation basically means constant with respect to time. Constant, something is constant over time. So time will pass, but they say, during LKG also this guy is same. Do LKG this guy was humble. Let us say one guy called Om Narayan is humble, and when he does PhD also, Om Narayan is humble. So that is one of the examples you can say with respect to being constant, means that there is some kind of conservation. Okay, means it is protected. So linear momentum is conserved. So the rate of change of linear momentum will be 0. Means if you take linear momentum and differentiate it with time, it will be 0 because it is constant. No differentiation, you will learn differentiation of any constant is 0. So if you put momentum here, because you are saying conservation means it's constant with respect to time. So all this energy, moment, linear momentum, energy, angular momentum, charge, whatever you put it here, it will be equal to 0 because they are all constant over time, constant with respect to time. And energy can neither be created nor destroyed, but it can be transformed from one form to another form, right? I always tell this joke with my uh, friends and students. What is God? God can neither be created nor destroyed, but he can be transformed from one form to another form. Same things but different terminologies, right? So theologian gives the definition as God, whereas a scientist gives an example answer as energy. So yeah, there is some kind of connection there to talk and debate over all day and night. Actually, if you ask me, sir, so we have come to the end of this chapter. If you ask me, sir, what are the important things that we take away from this particular chapter, I would say this is the important topic, fundamental forces. So make sure you understand them. Rest of the things you might get test questions like in your class unit test or monthly test, whatever tests you will get in the class. For those things you might have to by heart some of these things, because you will know what is what by the end of the year. But the thing is, when you ask me for the final board exams or NEET or JE what type of question comes in, I wouldn't say any means hardly one question may come with respect to the forces. Okay, so that's how the distribution I see over the years. We will do more questions and problems also in the upcoming classes. If you want such type of things, please comment what exactly you need, how you want me to do. I will keep uploading the videos accordingly. And the frequency of upload will be based on the number of comments and likes, because I should know I give more attention to more people. So see you in the next class. Have a nice day. Please make the YouTube Baba happy by subscribing and pressing the like button. See you in the next class. Take care. Bye bye.